Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on October 21st, 2025, just yesterday. The hook is bold. This paper shows that turning long text into a single image can cut decoder token use by 38 to 58%, while keeping accuracy at 97 to 99%. The paper is titled, Text or Pixels? It takes half on the token efficiency of visual text inputs in multimodal LLMs, and as we'll see later, the implications for model efficiency are striking. Beyond retrieval, the method beats token pruning baselines on summarization, trims end-to-end latency by 25 to 45% on large decoders, and works best when images take roughly half the token budget. Alright, the introduction set the stakes around long contexts and rising token costs. Figure 1 shows a simple pipeline that turns a long context into a single image while keeping the user query as text. The top panel depicts the text-only path with about 90 tokens. The bottom panel replaces the context with an image that the multimodal model reads, so the decoder processes about 50 visual tokens and answers correctly with far fewer tokens. So, Figure 2 tests how far compression can go. Figure 2 shows accuracy versus the number of text tokens, while the image tokens stay fixed, with vertical dashed lines marking where text and image tokens are equal. The left panel indicates GPT 4.1 mini stays near baseline until roughly twice as many text tokens as image tokens, then drops sharply. The right panel shows QN 2.5 volts L72B. Instruct tolerates higher ratios before a steeper fall, which sets the safe compression range within 3 points of baseline. Well, Figure 3 extends that analysis by plotting text token tolerance against the number of visual tokens. The lines rise nearly linearly, which implies a stable compression ratio near 2 text tokens per 1 visual token, so decoder tokens drop by roughly half without accuracy loss. GPT 4.1 mini tracks this slope closely, while QN 2.5 volts L72B instruct supports slightly higher tolerances. The smaller QN 2.5 volts L7B instruct sits lower, indicating less headroom. So, while Figure 3 showed a near 2-to-1 trade-off, Table 1 lists concrete tolerances and accuracy. The table reports that with 783 image tokens, GPT 4.1 mini keeps 99% accuracy up to about 1,270 text tokens, which implies roughly 40% fewer decoder tokens. QN 2.5 volts L72B reaches similar accuracy with ratios that cut tokens by about 40 to 60%. Alright, Table 2 turns to summarization under matched compression. The table shows that rendering the document as an image outperforms select context and LLM Lingua 2 on every metric for both GPT 4.1 mini and QN 2.5 volts L72B instruct. Token budgets drop to roughly 40% of the original text, yet Rouge scores stay higher than pruning methods, and BERT score remains close to baseline. This means compression comes with better summaries, not just fewer tokens. Okay, 2 takeaways stand out. Turning long text into a single image can cut decoder tokens by roughly half while keeping accuracy within a few points of baseline, and it often beats token pruning on summarization while reducing latency. The broader implication is simple. Vision becomes an implicit compression layer, lowering costs for long context tasks. That is it for the AI Research Roundup. I am Alex. Thanks for listening.